Okay, so hi everybody. Today we're going to look at the ligaments of the upper cervical complex. First thing we need to consider is the job of those ligaments. Okay, so we're looking at stability. Stability is derived from all of the ligaments, so the joint capsules, the anterior and posterior atlanto-occipital membrane, the articulating surfaces of the joints, the way the axis and the occiput and the atlas all fit together. Ligamentum nuchae and the posterior neck muscles, also the anterior neck muscles. Importantly, the muscles of the suboccipital triangle have a role in posture and proprioception, so they are really deeply innervated with proprioceptive fibers and they're very important for that function. Okay, what we're looking at the moment is a drawing of the upper cervical complex. Okay, so here we've got the basilar portion of the occiput. Okay, here we've got the ring of C1 here, so the atlas, and here we've got C2 with the dens coming up through there. Okay, so if we're looking at this from behind, so posterior to anteriorly, and the posterior arches have been removed. Okay, so that's why you can see straight the way through to the anterior aspect. Okay, so first thing to think about would be the anterior atlanto-occipital membrane. Okay, we haven't got a picture of that to put on here, but basically this is a broad fibrous structure that connects the anterior margins of the foramen magnum to the upper border of the anterior arch of the atlas. So around the front it would connect the anterior border of the foramen magnum to the anterior border of the arch of the atlas through here. Okay, it blends laterally with the joint and is reinforced by the anterior longitudinal ligament. Okay, so that's really important structure, the anterior longitudinal ligament. You need to have a little look over that as well. It's basically a strong, thick, broad band around the anterior arch of the atlas to just below the anterior axial body. Okay, so it's a thickened band which runs through that area through there. The other ligaments, like the ligamentum flavum, attaches to the posterior arch of the atlas and the axis. Again, we can't see that on here. Okay, its superior attachments are to the lower border of the posterior atlanto-axial arch, and its inferior attachment is just inferior to the border of the lamina of the axis. Okay, at these levels, this is quite a thin membranous type ligament. Okay, and it's pierced by the second cervical nerves laterally as it runs through. Okay, so we can then look at the ligaments of the dens and of the atlas and the axis specifically. Okay, so we're going to start with the apical ligament. Okay, so the apical ligament goes here and is basically going to run pretty much like that. Okay, from the apex of the dens to the anterior margin of the foramen magnum. Okay, this fans out as it ascends between the alar ligaments, which we'll add in a minute. The apical ligament is separated from the anterior occipital membrane and the cruciform ligament posteriorly by fatty tissue that blends with it. Okay, but it also blends with the attachments of these, so the anterior atlanto-occipital membrane and the cruciform ligament at the foramen magnum, and it blends with the attachments of the alar ligaments at the dens. Okay, so if we now put on the alar ligaments, okay, so as we can see through here, the alar ligaments are quite thick and cord-like. Okay, now they're said to be approximately about 11 millimeters long. Okay, and they pass laterally from the posterior lateral aspect of the dens. So we've attached them to the dens through here, the posterior lateral aspect. Okay, over to the medial side of the occipital condyle. Yeah. Commonly, there are inferior bands that also pass from the dens to the lateral masses of the atlas, and these are anterior to the transverse ligament of the atlas. Okay, so we can see them just through here. Okay, so this would be attaching into the lateral masses of the atlas. The main function of these ligaments is to limit atlantoaxial rotation. Okay, so if you are going into right rotation, then the left-sided ligaments become tight, okay, or taut, and right-sided ligaments become tight on left rotation, and left-sided ligaments become tight on right rotation. Okay, so the reason we get a little bit more movement here, though, is because, as you remember, we talked about the non-linear rotation. So as the atlas rotates on the axis, we also get a change in height, so we get vertical descent, don't we? Okay, and that is what allows us to have a little bit more movement through. The tension isn't generated quite so quickly because of that height change, because of that vertical change in height. Okay, and then if we look at the transverse ligament of the atlas, okay, so I'm going to pop that across the top here. Okay, so we can see that the transverse ligament of the atlas is about 20, you can't see that, but it's about 20 millimeters long. Okay, and it attaches to the tubercles on the medial side of the lateral masses of the atlas. Right? It's broader and thicker and stronger at the midline, okay, where it's also covered anteriorly by a layer of articular cartilage. Okay, this is the point where it receives the dens. Okay, this is a really strong ligament, and it's made up mostly or almost entirely of collagen fibers that form an interlacing mesh, okay, due to the obliquely angled orientation of the fibers, which I've kind of tried to illustrate here by crisscrossing the fibers as we go through. Okay, so at the central point of the transverse ligament of the atlas, yeah, we have something called the superior longitudinal band. Okay, and this is a superior band which is situated between the apical ligament of the dens and the tectoral membrane posteriorly. Okay, we also have an inferior longitudinal band, okay, which runs basically to the body of the axis. Okay, together the transverse ligament of the atlas, the superior longitudinal band, and the inferior longitudinal band are known as the cruciform ligament. So if we just pop that over here, we can see this is basically a continuation. Okay, so we've now got the superior longitudinal band and the inferior longitudinal band all basically running off of the transverse ligament of the atlas. Okay, and that becomes a thickened sort of projection that runs up here to the anterior border of the foramen magnum and runs down here onto the body of the axis. Okay, that is now creating the cruciform ligament. So the tectoral membrane, which would go on sort of next, which would be through here, is a broadened sort of continuation and thickening of the posterior longitudinal ligament. Okay, it's attached to the posterior surface of the axis, okay, and it expands as it extends up into the vertebral column, and it connects to the dura mater as it attaches to the foramen magnum just around and also around the atlanto-occipital joint capsules. The cruciform ligament is separated from the tectoral membrane by a layer of fatty tissue, so areolar tissue, and also sometimes a bursa. And then over the top of that, or a continuation of that, we have the the posterior longitudinal ligaments, which should run sort of something like this. So there's a continuation of the fibres, but it runs further down and inserts into, well, follows the rest of the posterior longitudinal ligament down as it runs. So interestingly, or importantly, are the connections that we have. So the posterior atlanto-occipital membrane will run, it is relatively thin, and it runs sort of just anterior to the ligamentum, not ligamentum flavus, or the tectoral membrane, okay, and it attaches to the foramen magnum and posterior arch of the atlas, okay. So this does blend with the joint capsules. It arches over the recesses where the vertebral arteries and cervical nerves pass, okay, and these arches can sometimes be ossified. It's also seen as the floor of the suboccipital triangle, okay, and the important thing is it's normally attached to the rectus capitis posterior minor muscle via a soft tissue bridge, like a muscular or tendinous fibrous link, okay. Around the same point, it's normally firmly affixed to the spinal dura, okay. So it's a direct connection between your rectus capitis posterior minor muscle and your dura mater, okay. So it's a really important functional link that we have through there.